Hi everyone, good morning to you all. Welcome back to science class. In the last session, already we are discussed about the current flowing through a different shape of the conductor. We get the magnetic field, and the strength of the magnetic field is quite different in the different shape of the conductor. Today we are going to study some more new concepts in electromagnetic induction or about electromagnetic induction. What is electromagnetic induction and how it is very useful in our present day-to-day life, right? So first, electromagnetic induction. So this phenomenon is proposed by the Michael Faraday. Is an English scientist, Michael Faraday. He discovered or he proposed the electromagnetic induction in the year of 1831. So what he made an one breakthrough experiment in the branch of physics. What is that? So mainly the Michael Faraday is conducted an experiment. What is the experiment? So the experiment tells us when the moving magnetic field is used or moving magnet is used to generate the electricity. That experiment now I want to discuss with you all. So here first the Faraday taken one cardboard cylinder. Then he taken the copper wire, the length of the copper wire, and then the copper wire is wound around the cardboard cylinder, and the two ends of the copper wire are connected to a galvanometer. The copper wire is wound to a cardboard cylinder, then the two ends of the copper wire are connected to a galvanometer. Here, what is galvanometer? Galvanometer is an instrument that is used to measure or find out the presence of electricity. It's a device which is used to check the presence of electricity in a coil or in a conductor. Then later Faraday taken a bar magnet, that is two poles, north pole and also the south pole. The magnet is thrust inside the cardboard cylinder. Thrust means just placed or pushed inside the cardboard cylinder. When he thrust the magnet inside the coil or inside the cardboard cylinder, so there is a galvanometer, means there is a needle in the galvanometer. It shows the deflection. It shows the deflection from left to right. Again he pulled out the magnet from the coil or the cardboard cylinder. The galvanometer shows the deflection but in the opposite direction. It means from right to left. So once I'll repeat, my dear students. When he thrust the magnet into the coil, the galvanometer shows the deflection from left to right. Then when he pulled out the magnet from the coil, it shows the deflection but in the opposite direction. Later, he repeated this activity. Okay, so when he increased the speed of the magnet into the coil, deflection is more. When he taken out of the coil, when he taken out of the magnet from the coil, the deflection also more or increase. And next, he thrust the magnet into the coil and kept in the coil only. Means now the magnet and the coil both are at rest. There is no motion. So no electricity. Galvanometer do not shows the any deflection. Why? Because magnet also at rest. So when the magnet is linked with the conductor changes, there is a electric current is produced. When the magnet and the conductor is at rest, there is no electricity. So here the electricity is called as EMF, electromotive force. So when the conductor is in motion, or when the magnet is linked with the conductor, there is a EMF is produced. When the conductor and the magnet both are at rest, there is no electricity. It is a breakthrough experiment from the Michael Faraday, and it's a very great invention of the Michael Faraday. Then later he explained about electromagnetic induction. What is electromagnetic induction? When the magnetic field is linked with the conductor changes, when the magnetic field is linked with the conductor changes, an induced EMF is in the circuit. Means EMF is produced. EMF means electromotive force is produced in the circuit. And later Michael Faraday proposed the two laws of electromagnetic induction, the first law and second law. What is first law? The changing magnetic field is linked with the conductor changes. The first one, a changing magnetic field is linked with the conductor changes and EMF is produced. Second one, the electromotive force is directly proportional to the magnetic field linked with the conductor. So this is about some concept about electromagnetic induction. Dear students, one more new concept is Fleming's right hand rule and left hand rule. Before we discussed, the bar magnet is moving, and when linked with the conductor changes, the electric current is produced, right? So the direction of the electric current is produced. Okay, this can be easily identified by using the Fleming's right hand rule and Fleming's left hand rule. So first we have to discuss about Fleming's right hand rule. Fleming's right hand rule, right? Look at here. So here mainly arrange, firstly I will introduce one thing here, the main finger, forefinger and center finger. Main finger, forefinger and center finger of right hand. So now I will start. What is the Fleming's right hand rule? Okay, so arrange the main finger, forefinger and center finger of right hand which are perpendicular to each other. Then the main finger indicates motion of the conductor, forefinger indicates magnetic field, and the middle or the center finger indicates the induced current in the conductor. This is written here. So the thumb indicates motion of the conductor, forefinger indicates magnetic field, and the center finger indicates induced current. This is called as Fleming's right hand rule. Now left hand rule. Arrange the main finger, forefinger and the center finger of the left hand which are perpendicular to each other. Then the main finger indicate the force act on the conductor. And forefinger indicates magnetic field, and the center finger indicates the current produced in the conductor. So this is about the Fleming's right hand rule and left hand rule. So these Fleming's right hand rule and left hand rule are very useful to check the direction of the current, direction of the magnetic field in the conductor changes.